Okay, you're welcome back once again. My name is Victor Digomo here, and in this class, we are going to be looking at another example that can help us to understand elevations and depressions. Once again, I want you to take a look at this while I put up the diagram.
So, do you realize that it will take somebody who is on a higher height to be able to see the top of the roof of this building? Okay, so the height where I am is higher as compared to the height of this building. And also take note that this building has height. The building you are seeing also has a height. Okay, so I can say now that there is an angle of depression from the point where I am to the top of the building. Okay, so you can also show it in a diagram form.
Okay, so if you look at this, it has to do with a question. This question says it's just a typical illustration of what you just saw in the demonstration I gave that you saw there. Okay, that little demonstration I gave tries to project this question we're about to look at, that says from the top floor of a story building, the angle of depression of another building's roof 20 meters away from the base of the story building is 58 degrees. Okay, it says if the roof of the building is 4.5 meters above the ground, what is the height of the story building? Okay, if you look at that demonstration, you see that it's really so. Whenever we are talking about elevations and depressions, elevations has to do with heights above the ground. Okay, so from those heights, it's either you are from the ground, you are looking at the top, which is you are observing an elevation, or from that elevated top, you are looking at the ground, which is a depression. Okay, so all this calculation we'll be doing, we just be hovering around elevations and depressions. And I'm trusting God that that demonstration I did was able to help you to understand what we are talking about in a depression. So let's look at this diagram that I'm trying to put up here to capture what we are trying to say. So in that question, if you look at it, it says from the top floor of a story building, the angle of depression of another building's roof 20 meters away. So you see, this is the smaller, like the smaller building, right? And this smaller building is 20 meters away. That is to say, this distance from here to here is 20 meters. Is 20 meters. Okay. So, and then being 20 meters away, and we are told that the height of this smaller building is 4.5 meters. It's 4.5 meters. Now, do you realize that this is a rectangle? And by properties of this rectangle, this height should be equal to this height. So this also should be 4.5 meters. And from here to here will also be 20 meters. And we are told that the angle of depression of the top of the building from that story building, from the top floor of that story building, this like that height where I am, and then this is the roof that I was looking at. Okay, so the angle of depression here is 68 degrees. Do you get that? Now, do you also realize that this line is parallel to this line? And because of that, this angle here is alternate to this angle. So here will also be 68 degrees. Okay, and what again do we still have there? I don't think there's any other thing left other than to calculate the question they asked us, the height of the story building. So if I label here, let's say A, B, C, D, and here M. So we are requested to calculate, calculate AB, calculate AB. Okay, so so not given. So if you look at it carefully, you realize that this AB is a function, a combination of, it's a combination of BM, BM plus AM. So I can call here, if I call here X, I think it's not wrong, and AM. Okay, so, and we know this to be 4.5 meters. Okay, what is left now is for us to calculate X. Do we get that? So what do we still need to use? Like as you can see in the previous class, I was emphasizing the procedures we use in solving problems of triangles. I was talking about the use of the Pythagoras theorem, SOHCAHTOA, sine rule, and cosine rule. All these procedures, we use them. And then, but in this case, whenever you are talking about a right angle triangle and one of the angles is given, you use SOHCAHTOA. So if you look at this place, you see the opposite side to this angle is what we are looking for, and the adjacent side is available. Combination of the two ratio, the opposite side and the adjacent side, gives you the tangent of that angle. So I can say solving for x, solving for x, I will say tan 60, tan 68 degrees is equals to opposite over adjacent, which is the opposite side over adjacent side, x over 20. If I cross multiply here, I will have that x is equals to 20 tan 68 degrees. So that will give us this. Okay. So we check the value of tan 68, and then 68 tan, and that gave us this is equals to 20 times 2.47 or 2.48. Okay, 2.48. Okay, and the product of that will give us 2 times 20. That will give us 49.5. 49.5 unit of measurement meters. So this is x. Do we get that? Now, therefore, I can now conclude that AB rather, AB, which is equals to 4.5 plus x, will now be AB equals to 4.5 plus 49.5. So if I add plus 4.5, 4.5, that will give me 54.0. So this will be 54.0 meters in meters. This is the height of the story building. So we are still going to have more calculations. Remember, these 4 procedures, we are still going to be bringing them and using them. You understand that we're still going to be just be walking around them. So you need to understand them, you need to master them, okay, and how to use them. So please, I'm sure that this explanation is very, very clear. Do share it to someone out there like what you are doing, and of course I know it has been a very much help to you. Please, if you subscribe to this channel, you'll be able to access many classes you've had previously across many topics. So I urge you to do that. And as you do, you will not regret. Thank you for being there.